Hello everyone. Today I will present you my tutorial to help you make a realistic flight model in SimplePlanes. Since a few years now, during my free time I test builds which are mostly airplane replicas, and I give my opinion and advices to the players. And I found that most of the time, builders will pay attention to the appearance of their builds, but not always for the flight model. So in this video, I will teach you the basics to make a flight model which is accurate to a real-life airplane. It may not be perfect, it's only my thoughts about this subject, enhanced by the point of view of other experimented players. But I think it will help you figure out the most important points you need to think about. Let's get in. So, you want to make a replica. For my part, I chose to build the Cessna Citation 5, a light business jet designed in the 70s. The first step will be to build the plane itself. But I'm not here to teach you that, so we will skip this part quickly. I highly recommend you to activate the Overload XML mod which is included with the game. This is a mod which allows to edit hidden settings for most of the parts, and we will use it a lot for this tutorial. Now we will focus on the flight physics. To understand how to make a good flight model, we will see the basics of how a real plane flies. As you may know, a plane is subject to 4 forces in flight. The first one is the weight. This is the result of the Earth attraction, which will make your plane stay on the ground, or make you fall down if you're above the ground. The second force, which counteracts the weight, is the lift. This force is vertical and is created when a wing-shaped object obtains a relative airspeed. This is what makes your plane fly. But as you understood, a plane needs to get airspeed to fly. This is the role of the third force, the thrust, which is made by an engine, like a propeller engine or a jet engine. This speed, however, will not be infinite, because it is restricted by the fourth force, the drag. This force is made by the air that comes into contact with your aircraft, and it acts in the opposite way of travel. It is proportional to the square of the speed. Making the flight model will be quite simple. In fact, we will try to tweak these different forces one by one. We will start by the weight. First of all, put the fuel where it should be. You can either choose to fill it in a fuselage, or by taking a fuel block and editing its capacity in liters. Take into account that the density of the fuel in SimplePlanes corresponds to jet fuel, so you can adjust its density if you use avgas. Then, adjust the weight of your parts to set a realistic weight and center of mass. Keep in mind that parts with slicing keep their original weight, so maybe think about editing their weight first. Details like paint can cause an excess of weight. By pressing your spacebar, it will show the center of mass of your aircraft in red. The center of mass, also called center of gravity, is a complicated data to obtain, so you can search for documents published on internet with the terms weight and balance. Otherwise, try to keep the center of mass at the same place when you reduce the weight. You can also refer to the characteristics of other similar aircraft. For my part, I found a great document about the Citation 5 with a scheme, then it was simple to adjust the center of mass in SimplePlanes. When it's done, we will look at the lift force. Start by putting wings with an accurate wing area. Add the control surfaces. Then hide them in the fuselage wing surfaces. You can scale down the wings to fit in the fuselage wings because they preserve their physical properties. Then add an engine with enough thrust to be able to fly the airplane and control it in the air. For information, it doesn't need to be realistic because we will tweak the engines later. Fly your airplane. Make a landing approach and note at which speed it stalls. Then adjust the wing area to have a realistic stall speed. When you do that, try to keep the center of lift at the same place. You can also edit the wing type instead, depending on the wing specifications you need. About control surfaces, there are 2 ways of making them. The first one is to use the stock control surfaces, and the second is to use one wing for the wing lift and another wing for the control surface. Each has its advantages and drawbacks, which I have summarized in this table so that you can make your choice. For roll, set the control surface wing area, then adjust the control surface angle to have a realistic roll rate. You can measure the roll rate by typing this command in the console. For pitch, set the control surface wing area, then monitor the maximum load factor that the aircraft reach with full pitch and a good speed. Try to adjust the control surface angle until the load factor is below the real limits. For yaw, the default settings of the control surface are generally correct, but of course you can edit them if necessary. Next, we will look at the drag. The drag is a big problem in SimplePlanes as the game tends to overcalculate the drag forces. A lot of people don't really understand that, and to solve the problem, they simply put a big amount of thrust in their engines, which leads to unrealistic accelerations and other performances. So, in any case, you will have to edit the drag. Here is a little advice about game performance. If your airplane has an interior, disable drag for all interior parts. This is because you don't really need your game to calculate the air drag in the cabin, considering there is no air moving through it. You can do the same thing to small exterior details like antennas, probes, livery details. To reduce the drag on your aircraft, you will have to reduce the drag scale on your exterior parts. To do that, you will have to measure the lift-to-drag ratio, also called glide ratio. For those who never heard about it, it's the ratio between lift and drag, which represents if an aircraft can glide far or not. It can be calculated by dividing the distance traveled by the altitude lost. For example, an airliner like an Airbus A320 has a glide ratio around 17, which means that in glide configuration, without any thrust, when losing an altitude of 1 kilometer, it would be able to travel 17 kilometers forward. For your SimplePlanes build, you will have to measure this value with a funky tree code that you can monitor with the console. It will be available in the description. To measure the glide ratio, you will have to stay at a constant speed. So for example, you will measure it at 200 knots, 180 knots, 160 knots, etc., until you find the maximum value the aircraft can reach. Generally, the best value is obtained at low speeds. Remember when I said that the drag was overcalculated in the game? Well, I just measured my default glide ratio without any drag modifications, and it gives me a value of 1.6 at its best, which is poor. Luckily, I found which drag ratio my aircraft should have, which is around 17. As other characteristics, if you can't find the glide ratio for your aircraft, you can search for any other similar aircraft. So by dividing 1.6 by 17, it gives me a result of 0.094. This number will be the drag scale for all the parts of my build. To edit an attribute of several parts at the same time, you can open the build file with a text editor and use this search and replace function. To avoid bugs, you will have to restore the drag scale to a value of 1 for several part types, like cockpit parts or flight computers, engines, wings. Also, you may need to readjust the drag scale to adjust the maximum speed of your aircraft and the drag made by flaps and landing gear parts, for example, because as you can see here, it floats too much in landing configuration. Finally, we will adjust the thrust of the engines. This is very simple. You just have to calculate the maximum acceleration with the formula thrust divided by weight, for example by using kilonewtons and tons. My aircraft currently weighs 15,587 pounds, which is 7.07 tons, and my engines can produce 12.9 kilonewtons each, so a total of 25.8 kilonewtons. This gives us a maximum acceleration of 3.65 meters per square second. You can measure the acceleration in meter per square second by typing rate of TAS in the console. Then, in the Engine XML section, adjust the power multiplier attribute to match this acceleration. For some builds, a funky tree input may be needed. The flight model part is now complete. Now I will give you some advices that are relative to other realism aspects when you build a replica. One major flaw that I see on SimplePlanes builds is the braking. This is because the stock value of the wheel's braking force is very high. In this case, you have to adjust the brake torque attribute of the resizable wheel part, depending on the landing distance of your aircraft, and to compare you can refer to the link in description for SimplePlanes runway lengths data. For more realism, you can even adjust the fuel consumption of your engines. For example, I know that my Citation 5 has a maximum flight time of 4.5 hours, and in SimplePlanes an aircraft with full tanks will output a value of 1. So it means it can consume each hour a value of 1 divided by 4.5. An exact value is 0.22, which means 22% of fuel per hour, and in seconds it gives a value of 0.0000611 units per second. In the console, you can watch the fuel consumption by typing rate of fuel. Then you have to edit the maximum input of your engines to edit their consumption. You can also calculate this value if you have real engine consumption data. Now, if you play the game, you must have heard about the sequel which will be published in 2026, SimplePlanes 2. It will introduce a lot of new parts and game mechanics, but that doesn't mean that this tutorial is useless. However, making a realistic flight model for an aircraft will be a lot simpler. First, we will get more realistic wings with customizable performance and control surfaces parts to achieve better wing performance. Then there will be a whole new drag system in the game that will hopefully resolve the problems we had with the current drag system. The Citation 5 which I built will be available for download soon, with a complete version with interior and a second version which will be simpler and suitable for mobile users. I hope this tutorial was useful for you. You can share your questions or your opinion in the comments. Thanks for watching and have a nice day.